In this video help file, we're going to look at the quiz algorithm and the quiz design, and we're going to make very clear what those two things are. It's really important that we don't just start when we program going straight on to Scratch and actually just having a step-by-step guide. Okay, we really do need to help children to understand the process, because they need to be able to actually design and write and think through their own programs. That's what we're aiming to. We're aiming for them to have their own agency in programming. And they're not going to have that unless they understand how the thinking process is behind this. So nearly always what I would start with is a human quiz algorithm. Okay, and I would tell the children, listen, this has got nothing to do with code here. I don't want you to tell me anything about Scratch blocks. This is about how a human actually does a quiz. And I would give them a simple quiz question. I would think it through very much, and then I would ask them to work in pairs to just tell me all of those steps bit by bit by bit, or maybe jot them down on a whiteboard as well. Okay, so here's a quiz question. Let's say let's have 3 times 3. Okay, and then hopefully I'll give them some way of giving me the answer to that. They can write it on a whiteboard or shout out the answer after 3. Okay, and then when they shout out 9, I'm going to say something along the lines of, oh, okay, that's brilliant. If you said the answer 9, then well done, you can have a point. And if you didn't say the answer 9, then no points for you. Okay, now I'll do a couple of quiz questions like this, okay, and then I'll get them to think through those steps. What does a human have to do to actually do this quiz? Okay, what's the order of instructions? After a while, we give them a bit of time to do that, and then we'll go through this with them. So, nearly always children will say things like, ask the question first. But actually, we've really got to think of the question as that sort of first starting point. Alright, that's really, really important. And often children also miss out this next point, which is thinking of the right answer. Okay, because there's no much point having a question unless you've worked out what the answer is as well. Okay, and then, yes, you've guessed it, because we flashed it up earlier by mistake, you've got to ask that question as well, and that's important stage. And then some children will say, well, you've got to wait for the answer, and that's fine. Okay, there's lots of sort of micro steps to this as well. Okay, but we've got to collect in the answer in some sort of way. Okay, now I tend to model these very physically, so I'll have something like, I will say my right answer, and I will hold up my left hand. Okay, and I'll say, well, my right answer is in this hand, and then I'll hold up my right hand and I'll say, and your answer that you have just shouted out or given me in some way is in this hand. And then I will look at both of my hands with a sort of questioning look on my face to encourage them to think, what does the computer need to do next? What do I need to do next? Okay, and often children will come up with words like, well, you've got to compare them. Okay, and then we might say, well, okay, let's be a bit more accurate than that. What do we really need to do? And they will say things like, well, they need to be the same. Okay, and that's brilliant. Okay, and then we'll say, okay, so does any of us know the mathematical symbol that means the same as? Because actually computers are very much built on maths, okay, and they will come up with equals. So actually we've got to compare those right answers with the answer collected, and they've already come up with this. Okay, and actually we're really saying, if the answers are the same, say correct and give a point. Okay, and if the answers are not the same, say wrong and take away a point. Okay, so that is our human quiz algorithm. And that's a great first step. Okay, but actually we have to do a little bit more work to actually turn that into something that's going to work for a program, because we have to turn that sort of human quiz algorithm into a sort of computerized quiz algorithm. Okay, so it's still away from the program, but we need to turn it. So let's talk those steps through with you. Okay, and I would really recommend that you talk these steps through with the children as well. This is a little bit like a model, right? It's giving them some understanding of what's going on underneath it before we even get into any of the code. Okay, so let's go through this computer quiz algorithm. Okay, so first of all, okay, we actually have to create a variable called score, and this is going to hold those points that we talked about earlier. Okay, and actually computers need somewhere to store stuff. I tend to think of these as bucket or boxes or containers of some kind, and that's a good analogy for younger children. It loses a bit when you get a bit older, but it's good for younger children. So we're creating this variable called score. Okay, and we're also going to use another variable called answer. Okay, and this is actually going to use the ask and answer blocks when we get to Scratch later, but actually, although it doesn't look like the other variables, it's not orange, it is actually storing some information for us to use, so it is a variable. Okay, so we're going to do those two things. They're sort of the behind the background things, a bit like in our human quiz algorithm. We have the thinking of the question and thinking of the right answer. We've got to create a variable and create a variable to store the answer as well. Okay, and then of course we've got to ask the user a question, very similar between the two algorithms. Okay, and we've got to store their answer in the answer variable. We've got to pop it inside that answer variable so we can do that comparison later. That's why it's quite useful to do those holding up both hands while you're doing it as well. Okay, so we've got to do that. And then we're doing that same sort of process if their answer stored in the answer variable is equal to or the same as the right answer, say correct and increase the score variable by 1. Okay, so that's that sort of first bit. And then conversely, if that doesn't happen, okay, their answer stored in the answer variable is not equal to the right answer, we've got to say wrong and decrease the score variable by 1. Okay, so you can see there's real links with that original human quiz algorithm, but they're not exactly the same. Okay, and it is useful to sort of draw this out before we actually go and program that, and that's the next video. But the quiz algorithm is not the only part of the design process. There is also what we might call quiz design. Okay, and this is thinking about the sort of bigger thematics of our quiz. Okay, and it's important that children get some sort of thinking through of this as well at some point in the process. Okay, I'm not saying I would necessarily put this straight away with our quiz algorithm. There might be a bit too much overload, but certainly it needs to be in there somewhere, and it could be before it, could be after it. Okay, so in some ways, do we want a theme for our quiz? Okay, now I've done this quiz lots and lots of times, and I'm 100% convinced that your maths quiz is the best thing to do that with. And I think a lot of this is down to the fact that we get short answers, and those answers are very easily seen as correct or not. Okay, most other types of quizzes tend to have lots and lots of different types of answer, and they're a little bit harder to do. And also, my children will often write sort of 10 or 11 or 12 questions for the time they might write 3 or 4 questions for any other type of quiz. Okay, so I might dictate that maths quiz, but I would want to give them lots of choice in everything else. Okay, so what sprite will ask the question? I'm sure they'll choose something more interesting than the cat. What will happen when they get the answer right or wrong? Well, we've already talked about points earlier. Okay, but maybe the children want to put some sounds in there or change the backgrounds, and there's all sorts of possibilities of things that they might want to do. What background will you put? Will you have a different background when you get the answer right and another background when you get the answer wrong? There's lots and lots of possibilities for doing this. Okay, and I think it is important to have both elements when we're actually thinking of our quiz, whether that's informally and allowing the children to choose these things, or more formally in just sort of putting some questions out there and getting them to think through. I know Jane Waite in some of her research paper will talk about the fact that if we get children to write some of this or draw some of this or sketch some of this in some ways, then we're taking some of that cognitive overload off them by, they can store it somewhere so that they can sort of refer to it as they go. Makes sense to me. Okay.